In this video, we will learn about double angle and half angle formulas. Let me state double angle formulas. Sine of 2x equals 2 times sine of x times cosine of x. Cosine of 2x equals cosine squared x minus sine squared of x, or we can state that as 1 minus 2 times sine squared of x, or 2 times cosine squared of x minus 1. We have a double angle formula for tangent also. Tangent of 2x is 2 times tangent of x over 1 minus tangent squared of x. Sine of 2x can be written as sine of x plus x To derive the formula for sine of 2x, we just use the sum formula for the sine function. The sum formula was sine of x times cosine of x plus cosine of x times sine of x. That was the formula from the previous section. Those are essentially the same, so we can combine to write 2 times sine of x times cosine of x. Double angle formula for cosine also was driven from the sum formula of the cosine. By applying the sum formula for cosine, we have cosine x times cosine x minus sine x times sine x. So that becomes cosine squared of x minus sine squared of x. So we apply the Pythagorean formula for the first one, then that becomes 1 minus sine squared of x minus sine squared of x. From here to here, we have cosine squared of x plus sine squared of x equals 1, which was the Pythagorean formula. So by subtracting sine on both sides, we could get cosine squared equals 1 minus sine squared of x. Then that can be written as 1 minus 2 sine squared of x. This was another formula we stated other than cosine squared minus sine squared, which was driven from the double angle formula, driven from the sum formula. By applying the Pythagorean identity again, we can convert this expression into the expression which contains only cosine. Cosine squared of x minus open parenthesis 1 minus cosine squared of x. In this case, we subtract cosine on both sides, then we get sine squared of x equals 1 minus cosine squared of x. So we can rewrite that as cosine squared of x minus 1 plus cosine squared of x. So that'll be 2 times cosine squared of x minus 1. Double angle formula for tangent also can be driven from the sum formula for the tangent function. For double angle formula, you don't really have to remember it, because as long as you remember the sum and difference formula for sine, cosine, and tangent, then you can easily derive all of those formula. Let's do the problem. The problem is evaluating the expression under the given condition. The first problem is evaluating cosine of 2 theta. The given condition is about the sine value, and we know the angle is in the third quadrant. We have to use the double angle formula for cosine. By applying the sum formula for cosine, we have cosine squared of theta minus sine squared of theta. In this problem, the condition is about sine of theta, so we want to re-express cosine squared of theta by writing 1 minus sine squared of theta. What I applied was the Pythagorean identity, then minus sine squared of theta, which came from here. Then it became 1 minus 2 times sine squared of theta. What we observe from this expression is all we have to know is sine squared of theta. If you square the number, everything will become positive, and it doesn't really matter which quadrant theta belongs to when you calculate cosine of 2 theta in this particular problem. So we have 1 minus 2 times minus 18 over 17 squared. We can ignore this minus because we have to square. So 1 minus 2 times this fraction squared will give us 64 over 289. 2 is 2 over 1. So that'll become 1 is 1 over 1, and we are thinking about the common denominator. Common denominator is 289. So we can re-express that as 289 over 289 minus 128 over 289. If you use your calculator, then that'll give you 161 for the numerator. Denominator is 289. So this is the final answer. If you're not sure whether that is the simplest form of the answer, then what you can do is you just put that in the calculator. 161 divided by 289, then get the decimal form of the answer. And then you can use this arrow button, then second and arrow. That'll convert the decimal form of the answer to the simplest fraction. That is identical to this answer. So this is the simplest form of the fraction. The second question is tangent of 2 theta when cosine of theta equals 7/25 and theta is in quadrant 1. We will use the double angle formula driven from the sum formula of the tangent function. Then that is 2 tangent of theta over 1 minus tangent squared of theta. So in the problem, we have cosine and the angle is located in the first quadrant. Cosine, this is x and 25 is r. When we use the coordinate form of the definition of cosine of theta was x over r. So let's draw the right triangle here. Here is x and here is r, here is y. X equals 7 and r is 25. So by using the Pythagorean formula, we know that x squared plus y squared equals r squared. We are now calculating r squared. R squared is given. So 7 squared plus y squared equals 25 squared. And y squared equals 25 squared minus 7 squared. We take square root on both sides. We don't care whether that is minus or plus because we are thinking about length. Everything is positive. If you put that in your calculator, then 25 squared minus 7 squared is 576. If you square root, then it'll give you 24. So y is 24. So tangent of theta, this is theta, which was defined as y over x, will become y, which is 24, over x, which is 7. So we calculated the tangent value. Then we have to plug that into here. Then what we find is a numerator is a fraction and denominator is also a fraction. We don't like it, so we rewrite the expression as 2 times tangent of theta times 1 over 1 minus tangent squared of theta. In this case, after we calculate 1 minus tangent squared of theta, we will flip it to get the reciprocal. Let's calculate 1 minus tangent squared of theta first. Then 1 minus tangent squared of theta is 24 over 7 squared. If you go through the calculation or use your calculator, then that'll give minus 527 over 49. So we can write that as 2 times tangent of theta is 24 over 7 and 1 over this is the reciprocal of minus 527 over 49. So we can rewrite that as 2 times 24 over 7, and minus is here, times reciprocal of that is 49 over 527. So that becomes minus 336 over 527. You will use your calculator and to think about whether that is the simplest form. You will check with this arrow button. This means fraction to decimal, decimal to fraction. The next problem is sine of 2 theta when tangent of theta equals minus 1/3 and cosine of theta is greater than 0. We have to use the double angle formula. So sine of 2 theta equals 2 times sine of theta times cosine of theta. This time, instead of quadrant, the sine of tangent value is given, and sine of cosine is given. Cosine is positive, so that is either in the first quadrant or fourth quadrant, because x values are positive in the first and fourth quadrant. Tangent, which is defined as y over x, is positive in the first quadrant. Tangent in the third quadrant is x is positive and y is negative, so that is negative. That indicates that theta belongs to the first quadrant. We will draw the right triangle in the fourth quadrant. This is theta. And another information we have here is tangent of theta equals y over x. Y is negative in the fourth quadrant, so y is minus 1 and x is 3. Let's write down x equals 3 and y equals minus 1. And then r squared equals x squared plus y squared, which is 10. So by taking a square root, we have r equals square root of 10. So r equals square root of 10. Then tangent is given, and sine of theta, which was defined as y over r, can be written as y value, which is minus 1, over r value, which is square root of 10. And cosine of theta, which is defined as x over r, is 3 over square root of 10. We will combine all those information because we need sine and cosine value. Remaining step is just this substitution. 2 times sine is minus 1 over square root of 10 times cosine is 3 over square root of 10. If you multiply all 3, then that is minus, so 2 is 2 over 1, and then 2 times 3 is 6 over square root of 10 times square root of 10 is 10. Then that equals minus 3 over 10. By simplifying, that's all for the double angle formula. Let's move on to the half angle formula. Half angle formula can be driven by using double angle formula of cosine. All you have to do is after you fix 2x as x and x as half of 2x, so x over 2, you will solve for sine or cosine to get half angle formula. I will not go through the details. Sine of u over 2 is plus or minus square root of 1 minus cosine of u over 2, and cosine of u over 2 equals plus or minus square root of 1 plus cosine of u over 2. And tangent of u over 2 is 1 minus cosine of u over sine of u. That equals sine of u over 1 plus cosine of u. You have to remember this half angle formula. In this half angle formula, we have plus or minus sign. While we evaluate the sine or cosine value, the value should be exactly 1. So the way we determine plus or minus will be by considering the quadrant the angle u over 2 belong to. Let's go to the next problem. Find the exact value of the expression the first one is sine of theta over 2 when cosine of theta equals minus 12 over 13 and theta is between 180 degree and 270 degree. We have to use the calculator, the formula, not calculator. To do that, the first thing we have to determine is which quadrant this half angle belongs to. The angle theta ranges between 180 degree and 270 degree. If we multiply by 1/2 on each side, then that'll be 90 degree, between 90 degree and 135 degree. Then the quadrant this angle belongs to will determine the value of sine of theta over 2. 90 degrees is here and 180 degrees is here. So this angle ranges in the second quadrant. In the second quadrant, sine value is greater than 0. So when we apply the half angle formula, we will forget this and then we will calculate this part. Let me write down the formula again. Sine of theta over 2 equals square root of 1 minus cosine of theta over 2. Fortunately, in this problem, cosine value is given, so all we have to do is substitution. However, if you replace cosine of theta by this fraction, then that'll be fraction over number. We don't like it, so let's separate it. 1 over 2 times 1 minus. Cosine of theta is another expression of 1 minus cosine of theta over 2. Then let's do substitution. Then that is square root of 1 over 2 times 1 minus 12 over 13. We just do substitution. Then that equals square root of 1 over 2 times 1 plus 12 over 13. So 1 is 13 over 13. When we calculate that, we have 1/2 times 13 over 13 plus 12 over 13. That equals square root of 25 over 26, because that is the common denominator. We can separate the numerator and denominator. Then square root of 25 over 20, square root of 26, square root of 25 is 5 over square root of 26. Cannot be simplified. So that is the final answer. You don't have to rationalize it. The second question is tangent of 22.5 degree. If you look at the problem, the first thing you can observe is 22.5 degree is smaller than any other well-known angle. So what you can do for this type of problem is you just multiply by 2 and see whether that'll give you the well-known angle. If you use your calculator or if you just calculate it, then that is 45 degrees. So 45 degree is a well-known angle, and we can re-express 22.5 degree by using 45 degree. 45 degree divided by 2. So half angle of 45 degree. We will use the half angle formula of the tangent. Then that'll be 1 minus cosine of u over sine of u. So tangent of 22.5 degree could be re-expressed as tangent of 45 degree over 2. And if you use your the formula, then that'll be 1 minus cosine of u is 45 degree over sine of 45 degree. If you think about the value of cosine of 45 degree, then it's 1 over square root of 2, and sine of 45 degree is also 1 over square root of 2. So we want to re-express that as 1 over sine of 45 degree times 1 minus cosine of 45 degree. Then this one will become 1, let's write down reciprocal of sine of 45 degree, which is 1 over square root of 2. This value comes from sine of 45 degree times 1 minus, that is 1 over square root of 2. If you think about the reciprocal, then that is square root of 2 over 1. And in the parenthesis, the common denominator is square root of 2. So we can say that square root of 2 over square root of 2 minus 1 over square root of 2. To calculate it, then numerator is square root of 2 times open parenthesis square root of 2 minus 1 over common denominator square root of 2. So those two will cancel each other, and we get square root of 2 minus 1. That's the final answer. The next problem is cosine of 75 degree. If you think about the sum formula, then we combined two well-known angles to produce 75 degree. If you use the sum formula, then you will use 75 degree equals 45 degree plus 30 degree. But that is not the method we want to pursue in this section. We are learning the half angle formula. 75 degree is not a well-known angle, so what we want to do is we just multiply by 2 and see what happens. If you multiply by 2, then you will get 150 degree. The reference angle of 150 degree is a well-known angle, which is 30 degree. So we can say 75 degree is 150 degree over 2. We can re-express cosine of 75 degree as cosine of 150 degree divided by 2. We have to use the formula, and then we have to think about whether the cosine value is positive or negative in the quadrant the angle belongs to. We are thinking about 75 degree, which is in quadrant 1. So cosine value is positive. We use the half angle formula. So that is 1 plus cosine of u over 2. So 1 plus cosine of 150 degree over 2. Again, cosine value will be the fraction. So we want to re-express what's under the square root differently to 1 over 2 times 1 plus cosine of 150 degree. We are thinking about the second quadrant. This is 150 degree. The reference angle is 30 degree. In the second quadrant, cosine is negative. So this cosine of 150 degree equals minus cosine of 30 degree. That equals 1 over 2 times 1 minus cosine of 30 degree. Let's keep on going. That equals 1 over 2 times 1 minus cosine of 30 degree is square root of 3 over 2. And 1 can be rewritten as 2 over 2. We are considering the common denominator. So 1 over 2 times 2 minus square root of 3 over 2. So that is square root of 2 minus square root of 3 over 4. And we separate the radical sign to the numerator and the denominator. Then it'll become square root of 2 minus square root of 3 over 2. The next problem is sine of 5 pi over 12. Again, we can use the sum formula for sine in this particular case, but we want to practice with the half angle formula. To do that, what we have to think about is how to express that as a half angle of something. So half angle of something is 1/2 times another angle. Definitely, the numerator must be 5 pi. And when we multiply, you have to make 12. So the only possibility is 6. That means 12 pi over 12 can be perceived as half angle of 6 pi over 5 pi over 6. If we re-express that by using the half angle, then 5 pi over 12 can be written, the sine of 5 pi over 12 can be written as half times 1 of 5 pi over 6. The next thing you have to determine is which quadrant it belongs to, because we have a plus or minus is determined by the quadrant it belongs to. So this is 0, this is pi, that is 12 pi over 12. Half of that is 6 pi over 12. So that is pi over 2. The angle belongs to, this is 12. The angle belongs to the first quadrant. So sine is positive. So when we apply the formula, we don't put minus in front of square root. The formula went like square root of 1 minus cosine of u over 2. Let's write it down. 1 minus cosine of, this is the half angle formula, so the angle you have to put in here is the double angle of the given angle. So that is 5 pi over 6 over 2. We do the same thing. We don't like fraction on the numerator, so we will rewrite the expression as 1/2 times 1 minus cosine of 5 pi over 6. In this case, this angle belongs to the second quadrant because pi is 6 pi over 6. It is slightly less than that. The difference between these two angles will give us the reference angle. Reference angle is pi over 6. In the second quadrant, x values are negative. That implies cosine values are negative. When we re-express the formula by using the reference angle, then 1 minus cosine of pi over 6. So that equals square root of 1 over 2, 1 plus cosine of pi over 6. Here minus became plus. Then that is 1 over 2 times 1 plus square root of 3 over 2. 1 is 2 over 2, so we can rewrite that as 1 over 2 times 2 plus square root of 3 over 2, because the common denominator is 2. So that is square root of 2 plus square root of 3 over 4. If we put square root on the numerator and denominator, then that is square root of 2 plus square root of 2 plus square root of 3 over square root of 4. Square root of 4 can be written as 2. So the final answer is square root of 2 plus square root of 3 over 2.